Hello friends, turning moment drawing for 4-stroke internal combustion engine. Before going to this part, we will know what is a flywheel and what its function is. So basically flywheel is a thing which has huge mass comparatively in the parts of engine. This is mainly used in reciprocating engine, punching machine, wherever the energy source output is irregular. Maybe we will have only ones where we have only power output, and remaining things we will either give the power or the power will be 12, like those, to provide a constant power to remain to avoid the fluctuation of energy, to provide an average energy throughout the cycle. We will use a flywheel. This is a device. It has some mass, considerable mass. It will store the energy and give the energy in the cycle in the time where the energy is not getting out from the system. So example, we will have a 4-stroke engine, internal combustion engine, where the suction, compression and exhaust stroke we have to give the power. Mainly the compression stroke, the power is done on the steam by the piston. In these two strokes I have considered inertial force, so it is a partial negative and partial positive loops. So if we neglect the inertial force, it is purely negative, both of these exhaust and suction. So only where we get some work is in this part where the gas expand and the gas will give work on the piston, and piston will push the crank rod and crank will start to rotate. So here only we will get the power out. In the remaining three we will either give the power on the gas here and somewhat in a partial way. So to avoid the fluctuation of energy, the flywheels are used to avoid. We will not completely avoid, maximum to extent we will have a linear fluctuation of energy between some range. So many people will confuse with flywheel and governor. This is used to maintain the fluctuation of energy, and this is used to maintain the fluctuation of speed. That is a common difference. Both of them do the fluctuation in a much reduced manner. So we will have some schematic drawing, general drawing, how a 4-stroke engine turning moment diagram has been found out. Already in previous class we have been known about the torque equation, how we can derive torque equation from in terms of force from the piston and radius of the crank, and where the crank angle makes the inner dead center, and ratio between connecting rod length and radius. If these values are known, we can easily find out the torque. How much torque is there at individual angles the crank makes with IDC. So here suction, as you all know, in the engine inside, during the suction stroke, when it comes on, there is a vacuum created. Not exact vacuum, the pressure is much lower than atmospheric pressure on the so gas and air comes in, and after coming to IDC, the crank will the piston will go up due to the inertia while it coming down in the crank. So it start compressing the gas again. It start to compress the gas again. Now in the return stroke, the gas will expansion happening inside in this small area, and there will be a lot of pressure and temperature inside here. So now the work is done on the piston, so that again the piston goes down with a lot of force exerted on the piston. So that's why we are having huge positive. And here, as usual, teaming is the average torque needed to start rotate that flywheel. And during exhaust torque, now the work is done on the gas, that is a flue gas here, and it will go out. This is the basic idea how the turning on graph and crank angle is represented for a 4-stroke internal combustion engine and the first spark ignition. And I hope you understand.